The Alienware 51M is a thick machine with desktop level hardware inside, but serious levels of power equals serious levels of heat. So what sort of temperatures are we looking at with this desktop replacement? In this testing, I'll be taking a detailed look at thermals and seeing how much we can improve performance and temps with some simple changes. The Alienware Area 51M is available in different configurations. I've got the top-end model with Intel's 8-core overclockable desktop CPU, the i9-9900K, Nvidia RTX 2080 graphics, and 64GB of memory running in dual channel. You can find examples of different spec options as well as prices linked in the description. On the bottom of the laptop, there are air intake vents towards the back, and most of the air is exhausted from the two corners on the back, though there are also smaller vents on both the left and right sides towards the back. As for the heat pipes, well, as I saw at CES earlier this year, they're pretty massive, as you'd expect for hardware like this. The Alienware Control Center allows you to run the laptop at stock settings or also pick between two built-in profiles, 1 and 2, and these are the settings that each profile gives us. None of the profiles perform undervolting, they basically just boost clock speeds. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. All of these tests are from combined CPU and GPU workloads and are meant to represent worst-case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the AIDA64 CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. All tests were also run with the fans at maximum speed. Let's start with the stress test results. At stock down the bottom, the CPU was thermal throttling at 99 degrees Celsius, as shown by the blue bar. Simply by applying a -0.15 volt undervolt to the CPU, we were able to drop the temperatures back by 12 degrees. When we enable the overclock 1 profile in combination with the undervolt, the CPU temperatures rise a couple of degrees, and the GPU also goes up by 4. If you recall earlier, this profile also overclocks the GPU, which equals more heat. Stepping up to the overclock 2 profile, which boosts the 8-core boost speed by 100 MHz, we're back to thermal throttling at 99 degrees. As the higher tier overclock requires more power, I had to drop the undervolt to -0.075 volts to keep it stable in this workload. And then when we add in the cooling pad, we're only seeing a small improvement to the GPU temperature. The gaming results are a bit better comparatively in terms of temperatures, not quite as intense as a synthetic test. Honestly, once we add the undervolt, even the overclock 1 profile isn't actually running too hot at all. So personally, I'd probably use it somewhere around this level to keep it from getting too hot. As you'll soon see, we're not really getting much extra performance from the extra heat. In any case, the cooling pad did at least make a bigger difference here compared to the stress tests. These are the average clock speeds for the same tests just shown. You'll notice that there's not actually all that much difference in terms of CPU averages over all 8 cores. Maybe a 350 MHz difference from the lowest result to the best result. Rather than tweaking for maximum performance, with these specs, I think it will be more important to make the changes to keep it running cool instead. In the stress test at stock, we're hitting thermal throttling, so just a lowly 4.5 GHz all-core speed on the CPU. Undervolting allows the CPU to hit the stock 4.7 GHz all-core turbo boost speed of the 9900K. And then with the overclock 1 profile with the undervolt, we're able to hit the newly defined 4.8 GHz all-core limit. It's worth remembering OC1 doesn't undervolt by default, but basically, if I didn't undervolt, the overclock profiles were useless in this workload, as we were already thermal throttling at stock with the fans maxed out. Applying overclocks isn't going to help us without first dropping those temperatures, hence the undervolting being essential to properly utilize the overclock 1 and 2 profiles in this stress test. Though this would not be the case in instances like gaming where thermal throttling is not hit, though of course depends on the game. The GPU also sees a nice clock speed bump here due to the overclock this profile applies, and then a little extra boost with overclock 2 which further raises the clock speed. With the second overclock profile, the all-core turbo boost speed is raised to 4.9 GHz. However, we're only getting a little extra speed here, as I had to lower the undervolt to keep it stable. We're hitting thermal throttling here, so this isn't all that useful, and nor would be adding more voltage, and the cooling pad didn't really help this out. The game test saw similar clock speed changes. though we were able to reach the full 4.9 GHz all-core turbo boost speed with the Overclock 2 profile here, with 2000 MHz on the 2080. These are the average TDP values during these same tests. The takeaways are that we're using a fair bit less power when undervolting is applied, which is why we see lower temperatures. Less power equals less heat, which equals more performance when thermal throttling is hit. Otherwise, the RTX 2080 was pretty crazy, spiking up to 190 watts at times. These are the average CPU clock speeds while under a CPU-only workload. At stock, we're able to hit the full 4.7 GHz all-core turbo boost speed of the 9900K under this workload, so no change once undervolted. If anything, this test is too weak for this tier of hardware, and maybe I should have used stressed FPU as well, given we're hitting 5 GHz with my manual overclock at the bottom. We can also see how much of a difference to thermals undervolting makes. All these tests with higher speeds are running cooler than the stock out-of-the-box results, which makes me wonder why Alienware didn't incorporate stable undervolt settings with the Overclock 1 and 2 profiles. My guess is that generally it's not something you want to do with such a high-powered CPU. Although in my testing, so far it's been good. The temps basically match the CPU TDP, as more power equals more heat. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks here. In this test, we're not really seeing that much of a performance boost. A couple hundred points depending on the customizations being made. In this workload, I couldn't get Overclock 2 working even with a lower undervolt, so I ended up giving up. So this profile doesn't really seem useful for multi-core load, as we've seen earlier, but may be more useful in games that don't thrash the CPU. So how do these performance boosts actually translate into games? I've tested with the exact same Windows, Nvidia, and game updates installed. Far Cry New Dawn was tested using the built-in benchmark at ultra settings. There's a bit going on here, so let me explain. I've got the laptop tested at stock in the purple bars, with the Overclock 1 profile in the green bars, then with the Overclock 2 profile in the red bars. Basically, we can see the Overclock 1 profile is giving us the best results, as by default the Overclock 2 profile seems to push it too far and cause high levels of throttling. Still better than stock results, but again, I think the Overclock 1 profile is a good sweet spot, especially if you undervolted. If you're after more gaming benchmarks from the Alienware 51M, check the card in the top right, where I've tested 15 different games at 4K, 1440p, and 1080p resolutions. As for the external temperatures where you'll actually be putting your hands, at idle it was sitting at about the typical 30 degrees Celsius average. With the stress tests going, the keyboard area is actually still quite cool, and only getting to 40 up the back. In the same test with the fan maxed out, it was a little cooler, only a little warm to the touch and quite impressive when you consider that in this test the CPU was thermal throttling at 99 degrees. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle, the fans were only just audible. With balanced mode set, it was definitely quieter compared to most other laptops tested, so you do have the option of sacrificing performance and thermals for quieter noise levels. Even with the fans at maximum, while it is loud, I've certainly had louder machines with much weaker specs that ran just as hot. Take the Aorus 15 for example. You might be asking why I've tested different volume levels of fans without also testing the thermals. Well, buckle in because I got a story for you. Essentially, the Alienware Control Center software is trash, or at least that was in my experience while using the latest version during my testing. You need it installed to use the overclock profiles and control fan speed. Basically, with the software installed, during both stress test and while gaming, the GPU power limit would drop every few minutes. You can see in the screenshot the maximum power was 195 watts, but the minimum was about 40. While it's currently sitting at 50 with a 390 MHz clock speed. This means that it thought it was operating at 100%, though the performance would suffer during these periods. You can see the historical GPU load bar is essentially the same, but the clock speed cycles up and down during these periods. Yes, both power bricks were plugged in. I even tried a clean install of Windows, but the problem persisted as soon as I reinstalled the Alienware software again. The only way to prevent this from happening was by removing the Alienware OC controls and the Control Center software. By doing this, the fans were stuck at whatever I last configured them to, which in my case was maximum. I also was never able to reinstall the OC controls no matter what I did. All sorts of errors kept coming up no matter what order I did things in. And I don't have time to keep doing fresh installs of Windows. Basically, after wasting over a day of troubleshooting, in the end I decided it was easier for me to manually apply the settings of the overclocking profiles with MSI Afterburner and Intel XTU, and just leave the fans at maximum so that I wouldn't have these dips in performance. I couldn't find very many instances of this issue happening to others, so it could just be my unit. There was one guy who posted online who seemed to think it was an incompatibility with having MSI Afterburner installed. However, I confirmed this was not the case after my clean Windows install. Just to be clear, it wasn't a reset. I tried that too, then after I downloaded a fresh 1903 ISO and installed from scratch. This was 100% some sort of software bug. In the control center, if I swapped between the different profiles while in a low performance period, it would reset the state and the power limits would boost back up for a while straight away. So while it should be possible for them to fix this issue severely impacted performance in my testing to the point where I had to rage quit trying to use it. However, I believe the data represented here shows what you'd actually get from using the software overclock presets normally, as I manually set the same settings that those use. Overall, I'm pretty impressed with the performance of this machine, software issues aside. Yes, out of the box with stock settings, it does run hot, and thermal throttles under a combined CPU and GPU stress test. However, with some simple undervolting, it was possible to improve this quite a bit. You really do need to undervolt it though to get the most out of it. As we saw, due to the thermal throttling, the stock all-core turbo boost speed wasn't being hit under stress test. This means enabling the overclock profiles is essentially pointless on the CPU side until we can bring the temperatures under control, though some extra GPU performance was still possible from these. Combining the settings with undervolting though gave excellent performance without the temperatures being too crazy. So it would have been great if Alienware could have incorporated this into their default profiles. Maybe next time. A cooling pad didn't help out too much here. Even while thermal throttling, clock speed boosts were not really seen. Though interestingly, the fans weren't crazy loud either. Don't get me wrong, 55 decibels maxed out is on the louder side, but it was possible to lower the fan speed at the expense of thermals, and when you compare it to other machines that I've tested that reach the same noise levels with far weaker specs, I think it's fair. This crazy machine is powered by two power bricks, which are 330 watts and 180 watts. And I didn't find the battery to drain during any of my testing, even with the overclocks. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results. Primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements. So don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. Additionally, undervolting, boosting fan speed, or using a cooling pad are much easier for most people to do anyway. And as we've seen, these tweaks did help improve performance of the Alienware 51M. Let me know what you guys thought of the 51M's thermals down in the comments. And I'm sorry that it didn't catch on fire like many of you were hoping. If you're new to the channel, you'll definitely want to get subscribed for the upcoming full review.